Can you swim? If you can, do you feel something interesting when you swim? If you can, so the question is, do you really feel that you are becoming lighter when you are swimming into water? Because that is the point of buoyancy. And of course, in this video, I shall explain how we can quantify the value of buoyancy and how to derive it from equations. So of course you know that in Archimedes' law the weightlessness was discussed, because when something or any object is fully submerged or partially submerged, some amount of water is displaced by the object. So the weight of the displaced water is equal to the upward thrust is acting on the surface, and that is called buoyancy. So in this case, I shall explain what is about buoyancy, and I know that you already know this figure, which is already given in your book. So students of English versions, you know that when you studied about the pressure and state of matter, you need to understand this topic clearly, because it is definitely important when we will be solving like the Archimedes laws questions. So buoyancy is that we can define when a body or any object is submerged partially or fully into liquid or gas medium. The upward, this is very important, upward resultant force that is acting vertically. This is very important, acting vertically, and that is the main reason for becoming lighter when it is submerged into the water. So you see, there is very important words to understand that upward resultant force acting vertically. So it means when something, any object is submerged into the liquid, then an upward resultant force will act. And we know that when any object is submerged into the water, that force is acting from everywhere. So now we need to find that what is the resultant force acting on it, and it's vertically. So what is the definition of buoyancy? You can say that the upward resultant force that is acting vertically on any object which is partially or fully submerged into liquid or gaseous medium. So what is going to be the next step? We need to find out what is the equation of buoyancy. Let us think one thing, that a cylinder is submerged fully into water. So we have the cross-sectional area of this cylinder PQRS, which is fully submerged into this water, is A. So this is the cross-sectional area. So we can think, let us think like the area of the cylinder is A. Okay. And if we think that the space from the surface of water, the height from surface of water is H1. So this is the height from the surface of water, and the bottom of the cylinder is H2. So if we understand the height of the cylinder, is H2 minus H1 is equal H. And of course we need to know the density of the liquid, which is rho, and also the acceleration due to gravity. Acceleration due to gravity is rho, is g. So we need to think this quantity before going to explain the buoyancy. Right now we think that is a cylinder PQRS is submerged, fully submerged into the water, and the height from the upwards. And now if we think that we know earlier that pressure is equal F by A. And now if we think that F is equal what? This is P and A. And we know that pressure at any point of liquid is P equal H rho G. We know it. So here we can say that actually F equal P is equal H rho G. So this is AH rho G. And now if this equation is okay, then we need to think two things. That we say that resultant force, as this cylinder is fully submerged, suppose this is fully submerged, then a downward force will be acting and upward force will be acting. And if we say that the upward force is F1 and downward force is F1 and the upward force is F2, so the resultant force would be F is actually F2 minus F1. Because we know that the pressure depends on height, as the base of the cylinder having more height, we can see apparently that more height, then the pressure would be high. So that is why the resultant force in this case, we know that F2 will be definitely greater than F1. And that is why the resultant force is that we know that F1 is working as it is downward working, and F2 is also working which is upward. So right now we need to think that downward acting force. The downward acting force is F1. So this would be A, the area is same because cylinder, H1 rho G, because the H1 is the height of the area of the surface, from the surface to the upwards of the cylinders. And then if we find out the upward acting force, we say this is F2, so this should be similar, but there should be H2 rho G. And now the resultant force, we know that F2 is higher than F1, so the resultant force F is actually F2 minus F1. So we know that if we divide like A H2 rho G minus A H1 rho G, so we can make a common from A rho G H2 minus H1, so we can have this one like this. Previously we do it, H2 minus H1 is the H, because if we subtract like H2 from H1, then this will be H. So we can say that F equal to A H rho G. Now we can say that resultant force AH rho G. So this is area and height. So as it is area and height, so this resultant force is actually the buoyancy. So buoyancy is AH rho G. So A cross H is V, that means volume. So V rho G is the buoyancy. So what is the meaning of V? This V is the volume of water that is displaced by the object. So it means that the amount of weight it loses when it is submerged into the water, it is equal to the volume of displaced water, or the weight of the volume of displaced water. Suppose the weight of this cylinder in air is 90 Newton, suppose. But when it is submerged into the water, it's become 82 Newton. That means it loses 8 Newton, because 90 minus 82 is 8 Newton. So it loses 8 Newton. So that 8 Newton is the lost weight of the cylinder when it is submerged into the water. And that is equal to the volume of the displaced water by the cylinder. Because we know that if we immersed anything into the water, it will definitely displace some water according to its body shape. So it means that the volume of the substance that is submerging into the water, it will displace that amount of water. and this V is the volume of that water. So V rho G is the equation of buoyancy. So whenever we understand that we need to calculate something in the calculations of physics problems in pressure and state of matter chapter, so whenever we see any data is given about buoyancy and asking about will it submerged into this water, will it sink, will it float, then we need to consider the buoyancy. And this V is the volume of that cylinder. This rho is the density of the liquid, not the cylinder. Density of the liquid, and this G is the acceleration due to gravity, which is actually 9.8 meter per second square. So now what we understand, the buoyancy is the resultant force acting upwards, and that force is working upward, and that is why the weight becomes lighter. And that is why, suppose anything is submerged into the water, it loses its weight because of buoyancy. So anything, so we know that a huge ship made of iron having huge weight is floating into the water because of that resulting upward thrust, which is buoyancy. So of course I shall explain it more in the next class, and I hope you understand this tutorial. And of course do let me know, is there any sort of recommendations from your side, and I hope this is very understandable the way I explain. And if you don't understand, please let me know that if you don't understand any part of this entire video and any of my videos. So well, I am wishing you happy study, and you please study well, and do let me know your desired study materials. I'll definitely upload. Take care. Bye.